continuation. This is the continuation of the question that we are treating on regression analysis. In today's video, we are going to be calculating the coefficients of determination of this question. Don't forget that in my previous video, I gave you the solution about the regression equation. That is how to find the predicted value of y. So, but in today's video, we're going to be proceeding to calculate the coefficients of determination. Probably if you have not watched the video on how I got the regression equation, you can proceed back to the channel and search for introduction to regression analysis. Then you can click and watch. Now, without wasting our time, the coefficients of determination is represented by this beta. This is beta r square is equals to SSR all over SST. This is the parameters that they use to represent the coefficient of determination, that is r square. And what coefficient of determination tells us? It tells us the effect of it tells us the effect of the input on the output. It tells us the strength of the input on the output. That is what the coefficient of determination tells us, and it is represented by this formula. You see all this, the formula, this SSR that you see here can be represented as this SSR is represented as, the SSR means the sum of the square due to regression, and it can be represented by this formula, the summation of the predicted value of y minus the mean value of y into bracket square. The summation of the predicted value of y minus the mean of y into bracket all square. So for the total sum of square, the total sum of square can be represented as this SST is equals to the summation of the real value of y minus the mean into bracket all square. So now this is the total sum of square, and it can be represented as this. This is the sum of square due to regression, and it can be represented by this. However, we still have another term, which is the error term. As you know that when we find the predicted value of y, there might be a slight difference between the real value of y and the predicted value of y. That slight difference is what is known as error. So therefore, the error can be represented by this equation SSR is equals to the summation of the real value of y minus the predicted value of y into bracket all square also. So this is the formula for O. It is E, not R. So this is the formula for calculating the sum of square that due to error. So now, but in my own case now, I don't need this, because I can easily calculate the sum of square due to regression and the total sum of square and divide it by each other to get the coefficient of determination. But in some cases, we might need this particular formula when we are dealing with other when we are told to calculate some parameter that is related to this formula. But in this case, I only need the coefficient, the SSR and SST. However, if you want to get the error, so you can proceed to get the error, because there is a relationship between the total sum of square, the sum of square due to error, and sum of square due to regression. The SST is also given by this SST. The SST is also given by sum of square due to regression plus the sum of square from the sum of square due to errors. Therefore, have you seen now, I can proceed to get this if I know the value of this. That is, if I know the value of sum of square due to regression and the sum of square due to error, I can proceed to get the total sum of square. But in this video, I will just calculate the SSR and SST directly, then substitute and get the value of my coefficient of determination by dividing both. Therefore, that's what I'm going to be doing now. Just follow me carefully. Now, let us proceed with our calculation. You see, this is the value of the sum of square due to regression, and this is the formula for total sum of square. Now, if you look at this formula, you will realize that for the sum of square due to regression, you realize that I still need the value of my predicted value, because I need the predicted value table, because the formula says predicted value of y minus the mean of y. So though I have my mean here, this is my mean 20.5, but I still need to find the predicted value of y. So therefore, I'm going to be having another table here. So for this, okay, this is the equation that we got. Let me write the equation here. this is the equation of the regression line. This is the equation. Predicted value of y equals to 5.52 plus 1.07 xi. Now this is the equation. Now I can erase this. Now I'm going to be having another table here now, which is for the predicted value of y. So I will have the predicted value of y in this place. Predicted value of y. The predicted value of y. So now let us proceed with our calculation. If you look at this, this is the equation that they gave us. This is the equation for the predicted value of y, which is also our what? A regression equation, don't forget. So therefore, the next thing I'm going to be doing is to substitute each parameters of x, because I have xi here. If I want to get the predicted value of y for this now, for this column, for these cells now, for this cell, if I want to get the predicted value of y for this cell, I will have to substitute 5 as my hex in this place. In this equation, I will have to substitute 5 as my hex I. And if I do that, I'm going to be having predicted value of y equals to 5.52 plus 1.07 into bracket 5. Now, when I substitute 5 as the value of my hex I, the answer is 10.87. I got 10.87. So the value that will be in this cell is 10.87. 10.87. I don't know what happened to the board. 10.87. So for the first cell, the predicted value of y is 10.87. For the next cell, instead of substituting 5 here, I'll come back to my column of x, which is 7. For the next cell, the value of xi is 7. So I'm going to be having 7 in this place. And when you substitute 7 in that place, the value will be 13.01. 13.01. So for this cell, I'm going to be having 13.01. So now, please, I'm only substituting xi because I have xi here, and this is the column for my xi. So for the next column now, I'm going to be having 9 instead of 7. I'm going to be having 9 in here instead of 7. And when I substitute the value of 9, the predicted value of y is 15.15. 15.515. So that is how you are going to get all these cells. That is how you are going to get all these cells. Just go back to the regression equation, substitute each value of x, and for this cell like this, I'm going to be substituting 12. For these cells, I'm going to be substituting 14. For these cells, I'm going to be substituting the corresponding xi. That is how to calculate these cells. I substitute each value of x in each corresponding cells. I got all this. So therefore, I'll go back to my formula now. I've already got the predicted value of y, and I have the mean value of y. The next thing is to look for the predicted value of y minus the mean value of y. That is the next table that I'm going to be preparing now. Don't forget that it is the formula that gave me the table that I'm going to be having, because the parameters I named in my table, once it is completed, I can go ahead and substitute the value of this parameter. But I have not completed this. I have to find the predicted value of y minus the mean value of y, and that is the next table that I'm going to be having now. So therefore, I'm going to be having this the predicted value of y minus the mean value of y. So I have here another table like this. Now, the predicted value of y is here. I have my predicted value of y, and the mean value of y. Don't forget that I've already calculated it in our previous video that I dropped on the channel. I have already calculated it. So therefore, if I want to get this cell now, I will take this 10.87, subtract it from the mean value of y, which is what, 20.5, and the answers to that is minus 9.7, minus 9.63, minus 9.63. So for the next column, for the next cells now, I'm going to subtract the predicted value of y, which is 13.01, subtracted from the mean value of y. This is the mean value of y, 20.5. The answer that I'm going to be getting is minus 7.49. Minus 7.49. For the next cell, I'm going to be subtracting the predicted value of y, which is 15.15, subtracted from this 15.15 minus 20.5. That is minus 5.35. Minus 5.35 minus 5. Minus 5. 5.35. And for the next cell, which is this cell, for this one I'm going to be having 18.36 subtracted from 20.5, that is minus 2.14, minus 2.14, minus 2.14. So that is how I'm going to get the value of this cell. Subtract your predicted value of y, subtract it from the mean value of y. Okay, when I subtract this column, when I subtract it from the mean value of y, these are all the value that I have in these cells. Now I've already calculated the predicted value of y and the predicted value of y minus the mean value of y. How do I got? Let me go back to my formula and see what's next. The next thing is to square the predicted value of y minus the mean value of y, because you can see in this place this represented square. So the summation is what we give my sum of square due to regression. That's what I'm going to be calculating now. That is the predicted value of y minus mean value of y squared. So I will have another table like that. Predicted value of y minus the mean value of y all square. So I'm going to be having another table like that. But let me transport this. I'm going to write this back. So let me add this like this. So I have another table like that. Now what I'm going to be doing is to square the predicted value of y minus mean value of y, because I've already gotten what is in this bracket. I've already gotten it. I only need to square it now. Now if I square minus 9.63, the value is 92.74. 92.74 for the first cell here, 92.74. When I square minus 9.63, I got 92.74. Then square minus 7.49. That answer will be 56.10. 56.10. For the next cell now, I'm going to square minus 5.35. The square of that one will be 28.62. 28.62. Then for the next cell, which is this, I'm going to square minus 2.14. Minus 2.14. If you square that, you are going to get 4.58. 4.58 in here. 4.58. So if you square 0, you are going to have 0. You are going to square 6.42. If you square 6.42, you are going to get 41.22. 41.22. So that's how you are going to get these cells. If you square this, you are going to square this also. For the 7.49, if I square 7.49, my answer is 56.10. 56.10. And for the 10.70, if I square 10.00, I got 114.49. 114.49. 114.49. So that is how to get the value of this column. You square the predicted value of y minus mean value of y. Okay, now we have already gotten the value of predicted value of y minus the mean value of y square. This is value I got there. And go back to my formula. The formula says I should sum it. This, of course, this sign means summation. So I'm going to be summing the value of this column, and when I sum it, I got we're going to add all this together, add all this together. The final answer will be 393.85. 393.85. 393.85. Therefore, this is the value of the summation of this. So I've already gotten the sum of square due to regression, which is what? 393.85. Now let's proceed to the total sum of square. As you know that the determinant of my coefficient of determination is based on the sum of square due to regression divided by the total sum of square. Therefore, for this value now, for this total sum of square, I'm going to look at the parameter that I have in here. If you look at this, I have here the real value of y minus the mean value of y into bracket all square. Now, before you calculate any parameters, check the headings, check the table that you have. Probably you have already calculated this. You have already calculated this parameter. Now let's check. If you look at this, I have this parameter here. The parameters that is inside this bracket, I have it here, which is what? The real value of y minus the mean value of y, but it has not been squared. So therefore, the next table will be the squared of this. If you look at this, I'm going to be squaring this to get all this. That's what I'm going to be doing now. So therefore, I'm going to be having another table like that, which is for the real value of y minus the mean value of y all into bracket all squared. So for this now, I'm going to be having. Okay, now let us proceed with our calculation. Therefore, I'm going to be squaring this value, which is minus 8.5 for these cells now. This value belongs to this cell, so I'm going to be squaring minus 8.5 squared, and when I square it, I got okay. Now let us proceed with our calculation. Therefore, I've already written another column. The next thing I'm going to be doing is to square all the value that is here, because I have my y high minus mean y here, but I need the value of the square. Therefore, I'm going to be squaring all the value that is in this place. And for the first column, for the first cell here, I have minus 8.5. So when I squared minus 8.5 squared, the value is 72.5. 72.5. For the next cells, for these cells, I'm going to square minus 6.5. Minus 6.5 give me the square of minus 6.5 is 42.5. 42.25. For the next cells, I'm going to square minus 4.5, and that value is 20.25. 20.25. For the next cells, I'm going to square minus 2.5. If I square minus 2.5, the value is 6.25. 6.25. Therefore, for the next one now, I'm going to square 15. Don't forget, I'm squaring this because the formula says that I need the summation of my real value of y minus the mean value of y into bracket or square. And I have my real value of y minus the mean value of y has this. So the square of this will give me what I'm looking for. So for the 15 square, okay, for the 1.5 square, I'm going to be having 2.5. These cells will have 2.5. So for the next cell, which is this, I'm going to square 3.5. 3.5 square will give me 12.25. I have already gotten all the column here. Now go back to your formula. You see, the formula said that I need the summation. This time is summation. Summation of y high minus the mean value of y into bracket all square. So therefore, I'm going to be summing all these columns together. And when I sum this column, the value is 318. 318. So now I've gotten the summation of this square, which is 318. The next thing, let me put it here, 318. Okay. I've already gotten the value of my sum of square due to regression and the total sum of square. The next value I'm going to be getting, I can proceed to calculate my house square. House square is the coefficient of determination. So let me have this equation cleaned. So therefore, the value of house square is equals to SSE, sum of square due to sum of square due to regression all over sum of square due to total sum of square. So and the sum of square due to regression from our calculation is 393.85, which is this, and the total sum of square is 318, which is this. So when I divide the value, the answer is 1.24, approximately 1.24. So the coefficient of determination is 1.24. That is how to calculate the coefficient of determination. In my next video, I'm going to be dropping video now how to test for 5% of 5% level of significance, because it's part of our question. And the first question is, what is the yield of 15 kilogram of fertilizers used? Therefore, I want you to pay attention to all the solving that I've been solving from the first video on regression analysis, so that we will not make mistake. Now, before we got here, we have already solved our regression equation. Of course, our regression equation tells us the predicted value of y. That is how I got my predicted value of y. So after getting the predicted value of y, I proceed to the predicted value of y minus the mean value of y. After that, I square it. Then I got, for the total sum of square, the real value of y minus the mean value of y, which is 318. Then I got this. Thank you very much for watching this video. Probably, if you have not subscribed to the channel, kindly hit the subscribe button. And if you have any question concerning this, click on the comment box. I'm going to attend to every question. Thank you very much for watching. Bye.
On this channel, you will find information, concepts explanation, tutorials video with detailed explanation that will assist you in gaining more knowledge and insight. In addition, our channel features past question, solution to questions you are likely to encounter in exam, solution to all past questions. Please kindly subscribe.